Welcome back to my YouTube channel. In today's video, we will discuss about combinational logic gates. In our previous videos, we discussed about AND gate, OR gate, NOT gate, as well as NAND gate and NOR gate. Write down the Boolean expression and the truth table for the following logic gate. In such type of questions, first try to identify the type of logic gates connected. So here we have two logic gates connected, and what are the inputs? A and B. Okay, what is this? This is a OR gate. And what is the Boolean expression for OR gate? F equals A plus B. And what is this? It's a NOT gate. What is the Boolean expression of NOT gate? F equals A complement. And the output of OR gate will be the input of NOT gate. And here will be the final Boolean expression of this combined logic gate. Is the output, see this is the output for OR gate, as well as it is the input for NOT gate. What is the input of OR gate? A and B. According to that, you have found the Boolean expression for OR gate, which is F equals A plus B. And now here is F equals A plus B will be the output for OR gate as well as input for NOT gate. So after it goes through the NOT gate, it will get a complement. So it will be F equals A plus B complement. That will be a final Boolean expression, which will be F equals A plus B complement. As we found the Boolean expression, now we are going to find out the truth table. So there are two inputs A, B. So we will write the inputs first, A, B, and we'll name the output as F. A column 0, 0, 1, 1, B 0, 1, 0, 1. Now let's try to find how to get values for this column. So first 0 plus 0 would be 0 according to OR gate, and then the complement, get the opposite, that would be 1. Here 0, 1. According to OR gate, can you remember the OR gate truth table? When there was 0 and 1, it is 1. Then you get the opposite. Why here A plus B complement? First go through OR gate and then take the opposite value for, because there is NOT gate. So 0, 1 would be 1 according to OR gate. Then the opposite 0. 1 and 0. 1 and 0 would be 1 according to OR gate. But the opposite, as there is NOT gate, 0. 1 and 1, 1 plus 1 would be 1, but because there is a complement due to the NOT gate, you get the value as 0. So this will be your truth table for this combined logic gate. This is our next logic gate. So in here also we have to write the Boolean expression as well as the truth table. So when you get something like this, first try to identify the type of logic gate combined. So what is this logic gate? It is the AND gate. And what is the Boolean expression of AND gate? F equals A dot B. Dot means multiplication. I explained these all in the previous video. And what is this? This is a NOT gate. So what is the Boolean expression for NOT gate? F equals A complement. Now see here, the output of AND gate is the input of NOT gate. So here A and B is the input of AND gate, and the Boolean expression here, it would be F equals A dot B, and A dot B will be the input of NOT gate. A dot B go through the NOT gate, it will get the complement, which will be A dot B complement. So what is the final Boolean expression? It will be F equals A dot B and then the complement from the NOT gate. A dot B from the AND gate and the complement from the NOT gate. So if you see this Boolean expression, it represents the NAND gate. If you can remember the Boolean expression of NAND gate, the same Boolean expression is here. Now let's find the truth table for this combined logic gate. There are two inputs A, B, and we can write the output column as F. A 0, 0, 1, 1, B 0, 1, 0, 1. So to find the values of F, first get the A dot B value, that is the AND gate value, and then complement for NOT gate. So first 0 dot 0 would be 0 according to AND gate. And then the complement, that would be 1. Here see 0, 0. When it goes through AND gate, it would be 0. And when it goes through NOT gate, it would be 1. And then 0, 1. 0, 1, A dot B. According to that, it would be 0. According to the complement, it would be 1. 0, 1 would be 0. And here, after it goes, it would be 1. And then 1, 0. 1, 0 would be 0 according to A dot B. That is AND gate. And then when it goes through NOT gate, it would be the complement. Complement of 0 would be 1. So here 1. Then 1 and 1. Here 1 and 1. According to AND gate, when all the inputs are 1, we will get the output as 1. And the opposite. The opposite of 1, 0, because there is NOT gate. So this would be the truth table for this logic gate, and this is the Boolean expression for this logic gate. In this logic gate also we have to write the Boolean expression as well as the truth table. So first identify the type of logic gates. So we have two logic gates. The first one is an AND gate. It has two inputs connected, A and B. C is connected to this and the output is P. So what would be the Boolean expression? P equals A dot B. P is the output and A and B is the input. Dot means multiplication. And what is this? This is also an AND gate. So here P Q equals A dot B dot C. So the final Boolean expression would be A dot B dot C. So that is the Boolean expression. Now let's find the truth table. So there are three inputs. So 2 to the power 3, which would result 8. So there would be 8 numbers in output A column, B column as well as C column. First fill out A, B, C, and then we'll figure out how to find Q. A is 0, B is 0 and C is 0. When A and B is 0, so what is AND gate? AND gate truth table, I told you in the previous video, all the inputs should have 1 to get the output as 1. So here 0, 0, which would result here 0. So P is the input of Q and C. So 0, 0 would result here 0. So here the result would be 0. Now you all try to pause the video and fill these values. Okay, let's now try to figure out how we got the other values. 0 and here B is also 0 and C is 1. 0, 0 would result 0 as AND gate. For AND gate, all the inputs should be 1 to get the output as 1. So here all the inputs are not 1. So here also it would be 0. So the second value is 0. Next, A is 0, B is 1 and C is 0. That 0, 0 would result 0. 0, 0 would result 0. So third value is also 0. Next is 0, 1 and 1. 0, 1 would result here 0. P would be 0. Then 0, 1 would result here also 0. That would be the fourth value. Next 1, 0. C is also 0. 1, 0, 0. So 1, 0. A and B are the inputs of this AND gate. 1, 0 would result here 0. Then 0, 0 would definitely result here 0. That's the value for the fifth. 1, 0, 1. 1, 0 result 0. 0, 1 result 0. Next 1, 1, 0. 1, 1 result 1. 1 and 0. Here how 1 came is in this AND gate. The inputs are A and B and both input has 1, so the output would be 1. Here 1 0. Now both the input does not have 1, so it would result 0. 1 1 1. Here 1 1 result 1. A and B has 1, so 1 1 1 again it results 1. So this is the way to get the values for this truth table. Okay, moving on. Write down the Boolean expression and the truth table for the following logic gate. First, I understand the type of logic gate. So what is the logic gate given here? It's an OR gate. And A, B, C would be the 3 inputs for this OR gate. And Q is the output. They have named the output as Q and the inputs as A, B, and C. So what is your Boolean expression? Q equals A plus B plus C. That would be your Boolean expression. Now let's find the truth table. First fill the A, B, C column and then we'll try to figure out the Q. So A 0 0 0 0 1 1 1 1. B 0 0 1 1 0 0 1 1. C 0 1 0 1 0 1 0 1. Now try to pause the video and find the values for Q. These are the values for the Q. So let's try to figure out how did we get it. A is 0, B is 0 and C is 0. So all the inputs are 0. Then it would be 0 according to OR gate. Now A is 0, B is 0 and C is 1. In OR gate, if either one of the input is having 1 or all the inputs having 1, then the output would be 1. Here C is having 1, therefore output would be 1. Next 0, 1, 0. Here also B is having 1, therefore output would be 1. 0, 1, 1. Here 0, 1. So 0, 1, 1. Both the out of 3 input, 2 input is having 1. So you can get the result as 1. 1, 0, 0. Still you can get the output as 1 as one of the input is having 1. Here A and C is having 1, therefore output would be 1. A and B is having 1, therefore output Q would have 1. Last one, A is 1, B is 1, C is 1. In OR gate, if either one of the input is having 1 or all the input is having 1, you can get the result as 1. So this is the truth table for this logic gate and the Boolean expression. Okay. These two logic gates are equal. This one we discussed previously. So the Boolean expression of this was Q equals A plus B plus C. The Boolean expression of this, here there are two OR gates. So this is the input, A and B is the input of this OR gate. This is the output of this OR gate as well as the input of this OR gate. So here A plus B for this OR gate, the Boolean expression A plus B. And this OR gate, A plus B is the input of this OR gate, but the output of this OR gate. So A plus B plus C. So this is same. If even the truth table, if you draw, it would be same. That's the end of this video. Like the video, subscribe and share among your friends. Thank you.